Okay, wonderful. Good morning, everyone. I hope you're having a great time here today. Finally meeting in person. Yes, no? Yes, perfect. Okay. Thank you for joining my session today. Today we are going to learn about TypeScript and how to use it with Lightning Web Components. And disclaimer, it is not as difficult as you think it is. So my name is Aditya. I work as a developer advocate with Salesforce. And I've been doing this for the past 3 years. So if you don't already know me, you should check out the Salesforce Developers YouTube channel. You'll find a couple of my videos, some blog posts. So basically my job is to let you guys know how best you can leverage the platform's capabilities and get the most out of Salesforce. Now, this slide should look familiar, a lot of content on there, but basically I might make some forward-looking statements today. So please don't make your purchasing decisions based on what I might say. Please make it based on generally available information. Now, what are we going to cover today? So we are going to cover what is TypeScript and why do you need it. And then we are going to go into how you can use TypeScript with Lightning Web Components. That is the core part of the session. Now, before we jump into TypeScript, so are you guys familiar with JavaScript? Yes, have you been developing with Lightning Web Components before? Okay, so how many of you love JavaScript? Show of hands. Okay, very good. How many of you find JavaScript frustrating? Very good. Can you tell me why? Anyone? Why do you think JavaScript is frustrating? Sorry? Okay. That's true. Okay. Syntax is weird. Any other reasons? Oh, yes. So that is exactly what we are here to address today. So before we jump into TypeScript, I would like to show you some JavaScript code. Is it like visible? Do I need to increase the font more? Okay. Now is it better? I can increase it more, but it will become very congested for me. Okay, so now what we are going to do is a very small exercise. So just look at the uncommented code for now, and we are going to deal with the commented code a little bit later. So can you tell me what will be the output of line number 2 and line number 4? Yeah, you will find all of this very frustrating because that is what JavaScript is. So any guesses on what line number 2 is going to return in line number 4? So any guesses? Line number 2, who says it's going to be 222? No one? Okay, anybody who's going to say it is 20? Okay. And what about line number 4? Is it still going to be 20? How many of you say it is 20? How many of you say it is something different? Okay. Is it 2? How many say it is 2? Okay, very good. Let's look at the output and see how many of you are right. So yes, line number 2 is going to return 20 and line number 4 is going to return 2. And the results are down here. Now, this is one of the frustrating things about JavaScript is called type coercion, which means until you run this code, you don't know what the data type of the output is going to be. So because it contains a string at the beginning, it's going to concatenate them and then subtract. Here it's going to add both the numbers and then it's going to subtract. So it's all dynamic during runtime. Okay, so what about this piece of code? What is the output of line number 8? Any guesses? How many of you say it is going to be 5? 5, okay. Let's look at the output. How many of you say it is not 5? Why is it not 5? Okay. Maybe you'll get a swag, I don't know, if you answer it correctly. Okay, as you see, it returns an error because array.size is not a function. Yes, because all of you have been working with Apex. That's how you get it in Apex. But in JavaScript, it is array.length, right? So those are the minor mistakes that you can make. Now, what about this piece of code? It's a little bit large, but there's an object, there are a few properties, and I'm trying to access a property. Am I going to get the correct output or not? No? Any reason why not? Sorry? Correct. So address is spelled wrong. I mean, it's a general noun, so you got it, but people make typos, and because of that, what you would get is again a nasty error. And when would you get to know that this is wrong? Only during runtime. And finally, let's look at the last piece of code, which is this. There's a function which takes in a string as a parameter, it converts it to lowercase, and I'm going to call that function now. Is this going to work? Is it going to return undefined, or is it going to throw an error? Sorry? Okay, people are afraid to answer. There is no wrong answer because it is all JavaScript. Okay, so and who says it's going to be an error? Who says it's going to be undefined? Okay, let's actually see who's right. It's going to return an error because it's trying to access a function of undefined because I haven't passed any value. So these are some of the gotchas of JavaScript, and now the reason all of this is happening. So I've written this code, I've saved it successfully, and I can even deploy it to Salesforce or anywhere else. But when am I going to get to know that there is an error? Only during runtime. And all of this is simple lines of code, so you can easily detect an error, but consider a production use case where there are hundreds of lines of code and you missed a null check at one method, and that's going to break all of your code. Now, TypeScript is introduced for this very reason, where it's going to help you catch all of these errors during development itself. So you need not wait for your code to run in order to catch all of these errors. So the exact same code, if I put it inside a TypeScript file, look at what happens. All of those red squiggly lines that you see, those are all the errors that TypeScript is going to show me right inside VS Code, even without me running my code. So for example here, it says size does not exist on type number of array. So right there I know I'm using the wrong method. Here I know there is a typo. And here I know there is some mistake I'm making when calling this code because it's expecting a parameter to be passed, the function, but I haven't passed it. So this is just a glimpse of what TypeScript can do for you. Now, what is TypeScript? It's actually a superset of JavaScript. So JavaScript has been there for quite some time now, and as you see, there are many issues that have cropped up during runtime, and TypeScript is going to help you solve those issues. And one more thing about JavaScript, you can take it both as an advantage and disadvantage. It's very flexible. So for example, I've used .size. It's not going to stop me from using it. I can call any property on any function and it's only going to throw an error during runtime. And there are no data types. As you see, the data types are also decided during runtime, as you've seen in the first example where we added and subtracted a few numbers. Now TypeScript is going to add that type system onto JavaScript. So now JavaScript is going to behave like your Apex, where you need to have definite data types and certain functions can only be used on certain data types. So that is the layer that TypeScript adds on top of JavaScript, and this is how it's going to look like. Plain old JavaScript with the TypeScript's type system is TypeScript. Now the thing with TypeScript is a browser cannot understand it, neither can Node.js. Both the browser and Node.js can only understand pure JavaScript code. So what we need to do is we need to compile TypeScript code and it's going to finally generate JavaScript back. So now what's the point of using TypeScript if the output is JavaScript, right? So TypeScript is majorly used only during your development cycle. So it has no effect on the runtime behavior of your code. So your code is going to work the same. It's just that the errors that come up during runtime, TypeScript can help you catch it during compile time itself. So as an example, here is some TypeScript code. We are going to go into the basics a little bit later, but there is a lot of code here. Once you compile it, it's the same JavaScript code that comes to you. So the type information that is this is going to be removed, and same is the case with all of these code. So it's the same function that gets converted into JavaScript, and there is no runtime behavior that is added. So for example, let's say I have a variable called count, and I say the type is number. Now, when I compile it, TypeScript is not going to add additional logic to check whether it is a number or to enforce that it is a number. All of this happens only during your development cycle. Your runtime behavior is never affected when you use TypeScript. So that is why we are in this session today talking about how you can use TypeScript during your development so that your runtime remains unchanged. Now, let's get into some basics. I think we'll see how you can write basic TypeScript code. So first and foremost, let's say you define a variable and you initialize it to something. Now, the way you define types is using the colon symbol, and then you define whatever data type it should contain. And it can be any of the primitive data types. You can have string, you can have number, or you can have boolean. And you can create complex data types, which we are going into a little bit later. So now that I've initialized a variable to a number, what happens if I assign it a string? You can see TypeScript shows me right there that string is not assignable to a number. Now, that's not just all. What if I assign a data type? It still shows me an error because TypeScript can infer data types on its own. Because I initialized a variable to a number, it's going to assume it's going to be a number throughout. So later on in the code, if I try to assign a string to it, it's going to throw an error. So that way, you can define data types and make sure you're using the same data type consistently all over your code. Now, what if you want to declare an array? So let's say IDs is equal to 1, 2, 3, 4. So now the way you declare arrays and assign a type is you specify the same data type and then you add these square brackets. So that's all you need to say, that it's going to be an array, and it's going to be an array of numbers. So what it's going to restrict you is you can only add numbers to this array. Let's say if you add a string, it's going to again throw you an error. So this way it's going to help you a lot during your development cycle. And not just that, because VS Code knows the type of a particular variable, the suggestions that come during autosuggest are contextual. So assume if this was a string array, it's going to return things that are related to an array. But let's say if it was just a string, assign it to 12, then you see the methods that are going to be returned during autosuggest are of the string data type itself. So this way VS Code is also going to help you with the right methods, right annotations, so that you don't end up running into errors. Now the next interesting thing, which we don't recommend at all, is the data type called any. So what any means is that this variable can hold anything. So let's say I initialize it to false, I use 1, I use a string. It's not going to throw any error. So it behaves just like JavaScript, and that is the reason we don't recommend the use of any. But why was any introduced in the first place? So whenever you're migrating your projects from JavaScript to TypeScript, you might want to start with this and slowly assign data types and slowly refactor your code. But in the end, once you've migrated all of your project, we don't expect to see any any's, because that's not a best practice at all. Now when it comes to functions, here is where it gets interesting. So let's say there is a function add which takes num1 and num2 and return num1 plus num2. And then I can call this function with two numbers. Now, how do I enforce that I can only send numbers to this function? So what I can do is for each of these parameters, I can define the type these parameters must contain. So I say both of them must be numbers. So what happens when I pass in a string instead of a number? It's going to throw an error saying it is not possible. So this way, when you're adding two numbers, let's say you've written an LWC code, you're trying to get two numbers from a text field. And whenever you try to call this function, it's going to throw an error saying that you're passing strings to a function that needs numbers. So obviously, you're then going to convert your string into a number using, let's say, the number function. Right? So this way, if you production, you would get the answer 22, maybe if you add 2 plus 2. But because of TypeScript, because you've defined both of them as numbers, you're enforced to convert string to numbers, which is why you're going to get 4 during runtime. So you will be absolutely certain that your code works as expected. And not just that, even the return types of functions find the type. So for example, after a function, I just put colon and add what is the return type of this function. So here it's a number. So return numbers. So let's say the return type of this function was void. It would again throw an error saying that I'm trying to return something from a function that is supposed to return void. So that way your coding practices are also enforced. So that's a little bit of basic. Until now we were only dealing with. Now what if you have a scenario where let sfid is equal to you have a Salesforce ID and it can either be a number or a string. So how would you tell this variable that you can accept both numbers and strings? That is where union types come in handy. So you can put the name string and use the pipe symbol for or and say number. So that way you will tell TypeScript that SFID can hold both string and numbers. So the scenario that comes up during LWC development is errors. So errors typically can either be string or an array of strings depending on what you're using it for. So for example, when you're multiple records at once, you will get multiple errors. But if you insert one record at once, you'll get a single error. But if you're assigning both to the same property, then this is the data type we recommend, using string or a string array. Now what we can do is, instead of writing the same statement everywhere, I can create what I call a type alias. Not me, but TypeScript calls it a type alias. So the way you create a type alias is you say type and whatever is the name that you want to give it, and then assign the same thing. What I can do now is, instead of using this lengthy statement, I can just use the custom type I created. So I define this once, and in my whole project, wherever there is an error, I can just use the error type. So that's the way you can work with types. And finally, moving on to objects. So this, again, in the context of LWC, most of what you're working with is an object. Let's say you're firing an event, it's an object. If you're retrieving records, inserting records, everything is an object. So how do you enforce the shape of an object using TypeScript? So I can again use the type keyword and define the name of a type. So for example, I am working with accounts. And here, because it's an object, I initialize it to the object syntax. And what are the properties that my object contains? So if it is ID, I specify the type string maybe, and name is again a string. So I've just created a type for my account object. So now when I try to create an account object and give it the type of account, so it's going to suggest. Again, VS Code is all good about suggestions because it knows what type it is. And I give it an ID, and let's say I don't do anything else. So you see, it says number is not assignable to string, so I get an error. I fix that. Then what happens? It says property name is missing in type. So you can enforce the shape with required fields and optional fields. So here's both of these are required. So TypeScript doesn't allow me to create an object without certain properties. I can mark them as optional using the question mark sign in the type. I just put a question mark and I can say that I can just create an object with one of these properties, but not all. So that's one way in which you can create objects. The other way is to use interfaces. So this interface is different from what you know in Apex. Interface is again a different way of declaring object types. So again, I can say type and it holds the same information. Now, the difference between the syntax using the type keyword and using the interface keyword is interfaces are extendable, but types are not. So for example, now I have two of these, but later on I want to say, I want to add a new field called isActive, which is optional and it is Boolean. So this is allowed when I use interfaces. So what I can have is a generic interface, and depending on my use case, I can add more properties to the interface. But if I would have used types, I wouldn't be able to do this. The type definition is once and done. An interface definition is extendable. Yep. The type can be used to declare type aliases and static types that cannot be changed later on. So it totally depends on your use case, on how strict do you want to enforce them. So if you would have used an interface, a developer is free to extend that interface based on their own code. But if you would have used type, they would have to reach out to you. If you are the one who's owning the types file, they would have to reach out to you in order to change it for their use case. Now with this, what happens? Again, not very different. So I can use ID, which is a string, and then isActive. Of course, I need to define the type. So it shows me in the suggestions that isActive is a property, and I can initialize it to false. So this is the way you create types, you create interfaces. All of this is going to become relevant in the next 5 minutes. This is just a high-level introduction to TypeScript. Now, one of the most interesting concepts about TypeScript is generics. So consider this piece of code. Very relevant to Salesforce again. You have a query function which can take a string, which is the SOQL query, and you can pass it whatever query that you want. Now, when it comes to type safety, the result of the query is different based on the query that you're sending. So for example, the account list here is going to hold account information if you pass in an account query, contact query. So the type of the output varies based on the input. So how do you enforce types in such a dynamic situation? So that is where the concept of generics is going to be helpful, where in the case of TypeScript, along with passing the actual data parameters, you can also pass in the type parameters to a function. So the way you do that is, in a function definition, you're going to use these angular brackets, and you're going to specify that it also takes in types as inputs. And what it is going to return is an array of type. So what this means is whatever data type I pass to it, it's going to return an array of the same data type. So that is the syntax of a generic function. So what I can do here is, for now, if you hover over this, you can see the type of account list is unknown. So I'm not going to get any benefits of autocomplete, enforcing the properties and all of that. Now watch what happens the moment I pass in a type using these angular brackets. The type of account list is now account array, and when I pass in contact, this is now a contact array. So now if I say ACC list of 0 dot, you can see the two properties of account type that I have defined. So this is how a generic function is going to help you with different kinds of data types without you having to do anything much. And all of this information is stripped away during compilation. So how does compilation work? before getting into that, a small thing. This is just one file in which I have defined some 100 types. Now, what if I want to share this with all the developers at once, because no one is going to be working on a project alone. Now, what you can do is you can create what we call a type definition file, which is a TypeScript file with the syntax name.d.ts. And you can have all of your type definitions in there, whether it is type, interface, whatever it is. And what you can do is in tsconfig.json, you can ask the compiler to look at this folder in order to get the types. Now, what is tsconfig.json? Just like in your sfdx projects, you have a configuration file, sfdx-config.json and all of those. For TypeScript projects, you have a tsconfig.json that tells the compiler what it has to do. So the compiler is the one that is responsible to assign types to all of your code. So I'm here telling the compiler that there are type definitions present in this folder. Please look at that and then enforce them in my code. So what happens? I can create all of my generic types in here, maybe push this to a GitHub repo, and any developer can make changes. Every other developer pulls down that code and the types are reflected in the complete project. So now that I have created this new order interface in my types.d.ts, in my code, I can just create a variable and use the new type, and it's going to show me the same suggestions from the other type. Now, this is actually a best practice that we recommend, that place all of your types in a specific TypeScript file and share that across all of your developers. Now, finally, the compilation process. So whenever you are trying to use TypeScript, you'll have to install a package called TypeScript in your projects. And what this package gives you is a compiler. And that compiler can be executed using any of your scripts, just like sfdx, pull, push, all of that. So I can simply run the command npm run build, and what it's going to do is it's going to generate this JavaScript file. Notice it's the same JavaScript file that we've been building all along, but all of the type information has been removed. But this code is definitely more robust than what it is if you would have written with pure JavaScript, primarily because we have enforced types during compilation. So all of my syntax is going to work just the same. I know that I'm using the correct statements, correct methods. So you need not worry about this breaking during runtime. So at a very high level, this was an introduction of TypeScript. But all of this is complex. You will have to learn a lot, how to define types, how to do all of this. How do you adopt this into your projects? So whenever you're trying to adopt TypeScript into your projects, you need not write all of your logic inside a TypeScript file. You need not install the TypeScript compiler and all of that. There are various levels of strictness that TypeScript gives you, which makes it easier for you to adopt the type system. If you look at the first 3 levels of strictness, you're actually working with a JavaScript file itself. You're not even creating a TypeScript file. So within your existing JavaScript files, you can start enforcing the TypeScript's type system to make your code better. And of course, it's not going to be as strict as TypeScript, but it's a start. You can start using these syntaxes, which is what I'm going to show you now. So the first and foremost thing is using the commented TS check in your JavaScript file. So the way it works is, let's take my basic JavaScript file from before. So this was the logic that was breaking, right? The very beginning that we have seen. This is perfect JavaScript, but what if I need to enforce the types? What if I need to enforce some type system on top of it? All I need to do is put TS check on top of the file, and it immediately shows some basic checks. So this is not the perfect implementation of a type system, It's just one step into adopting the type system. Now what happens here is the moment you put this, it's going to do a basic check. And what this basic check does is it infers a lot of types. So for example, here looking at the statement, TypeScript is intelligent enough to understand that this is an arithmetic operation being done and the left side should be of type any or whatever it is. It shows you there is some error. So this is the basic inference the TypeScript engine is already capable with just one line of code. Now what you can do is even further when you're trying to adopt this, the next step is to actually explicitly define what the type of a property is going to be. And you do that with the help of what we call JSDoc. Because it's a JavaScript file, the TypeScript types that you have seen until now, where I put the colon and I define all the types, that's all TypeScript syntax. How do I get the same information into a JavaScript file? And that is using JSDoc comments. And it's actually available online. So there is a reference documentation that is available, which tells you the syntax of writing comments. Now, the advantage with a JSDoc reference is if I go into the incremental file, you can see I put the TS check, but now I'm explicitly defining the types of these properties. So there is a specific syntax. I say @type, and what is the type of the next property? It's a number. So it's going to enforce the type accordingly. If I say it is a string, it's going to throw me an error saying that number is not assignable to a string. It's the same TypeScript feature, but inside a JavaScript file. And because all of this type information is present inside comments, commented code never runs in production. So your code never really changes. Your runtime is never really impacted. So without impacting the runtime, just using a few JSDoc comments, you are able to enforce the TypeScript's type system within your JavaScript file. And this is the first step into TypeScript world. Now you have a little bit more complex types. For example, defining an object. You've seen how to do it in TypeScript, but using JSDoc comments, it's a little bit verbose, but in the end, it's documentation. So you basically define the type of a property, and what it's going to do is if you're trying to use a property that is not present, it's going to throw an error. Same is the case with this file. So as you see, this is a neat way in which you can start adopting TypeScript into your projects. Now, with that in mind, what is the support of TypeScript in the Salesforce ecosystem? So you can use TypeScript in all of these places. So Lightning Web Components, Lightning Web Runtime, Salesforce Functions, CLI plugins, Slack apps, and Heroku. With Lightning Web Components, a small disclaimer, there is limited support for pure TypeScript. That means on the Salesforce platform, you cannot use .ts files. You only have to use .javascript files because that's what Salesforce can understand currently. And when it comes to enforcing types, in Lightning Web Components, you cannot enforce types between a HTML and JS file. So for example, you are creating a parent-child relationship between two components, and you're trying to pass a public attribute from the parent to child. That cannot be enforced using types. So for example, on the child you declare a property to be just a string, but from the parent if you pass a number, you can't validate that using Lightning Web Components, which is why we say the support is limited. But within a single component, you can use the JSDoc comments in order to get the type system in Lightning Web Components. So we are going to look at that with an example. So first things first, this is a Lightning Web component. All of you are familiar with it. All I need to do is put TS check here, and it's going to work just the same like the previous example. Any errors that you make are automatically going to be underlined. Now, do you have to put this comment in every single Lightning Web component? Let's say you have 100 web components. Do you need to add TS check to all of them? Actually, no. There's an easier way to do this, where I don't know how many of you have noticed this, but inside your LWC folder in the project, if you scroll all the way to the bottom, there is a jsconfig.json file. So this is the exact file that we have seen, either tsconfig.json or jsconfig.json. It controls the behavior of the compiler. So in the compiler options, all you need to do is write that one line of code called checkjs:true, and it's going to start enforcing the TypeScript type system on all of your JavaScript files at once. And if you find yourself with too many errors and you want to skip that one particular file, you would instead put ts no check to skip one or two files from the type checker. So that is the first step. You just put checkjs:true and all of your Lightning Web components will now start looking at types in order to make your code better. So here is a small example, a hello world component where I have a greeting, same properties. I use the js.comments. I say it is a string. For count, I say it's a number. So in connected callback, whenever I try to assign something else, it's going to throw an error saying that string is not assignable to number. And if I'm trying to use .push on greeting, which is a string, it's going to say you cannot push to a string because push is only valid for string arrays. So this is the best approach for on-platform Lightning Web components to use TypeScript. Now again, objects. You've seen this definition in the previous file that I've shown you. For contact, I have all of this large syntax. And I'm going to define the type in this way. Again, pure JavaScript doc comments. And what's going to happen? So just like that, when I say this dot context dot, because I've defined the type as an array, it's going to show me the suggestions based on that data type. And if I do of 0, it's going to show me the 4 properties that I have defined over here. So it's helpful, right? When writing code. Now, talking about sharing types between components, because again, sharing is the most important thing that we as Salesforce developers need to do. If you define a type in one of these files, you can actually import them into other files as well. So just import whatever is the file name and whatever is the type. So you define the type in one place and just import it into all of your other Lightning Web components. So you don't have to recreate all of your type definitions. Even better, you can actually create the same types folder. So for example, here is the types folder and here is my types.d.ts. This is the exact code I've shown you a little bit earlier in a different project. But inside your SFDX project, you create this types folder, define your types in there. And where do I need to tell the compiler that it has to look at these types? There is a file that I've shown you, right? jsconfig.json. So inside that file, in include, you just say, look at this place for types. So that's how you can again create a folder with all the different types, share that with all the developers, and everyone is using the same structure. In Salesforce, I find it particularly helpful because, where is that file? So here there is an order, and what happens if somebody creates a custom field? Now that custom field has to be added to this type, and it has to be shared across all the developers. So what you do is, there is a little bit of work to do. So whenever you create a custom field, you need to update this types file, push it to GitHub, and everybody else tries to pull that code. So there is some amount of work you need to do in order to create interfaces or types for all of your standard and custom objects that you're using. Unfortunately, at the moment, there is no straightforward way to get this done. So there is no button you can click and it generates types. Of course, we can all build that. We know how to create files from metadata. So if someone in the community is helpful, we can create this logic, press a button, and it gets the type file for us. So that's one of the ways in which you can use type system in Lightning Web Components. But off the Salesforce platform, if you're using Lightning Web Runtime, you can actually use .ts files in your web components. So here, it's the same Lightning Web component, but it's a TypeScript file instead of a JavaScript file. So whatever you have seen until now, where I have defined the types using the colon syntax, There is a return type that you can assign with functions. All of this syntax is possible with a TypeScript file in Lightning Web Runtime. And the best part with Lightning Web Runtime is you need not worry about creating a compiler, installing TypeScript. You just write your code in TypeScript, and the Lightning Web Runtime engine takes care of compiling it, running it, and showing you the output. So if you look at package.json, there is no TypeScript dependency. It's just LWC and LWR. So LWR is powerful enough to understand TypeScript files, compile them, and show you the relevant output. So if you are working with Lightning Web Components outside the platform, I definitely recommend look at TypeScript, because that makes your code more robust, and there is no overhead on you to install more packages to work with more build scripts. So that's pretty much in a nutshell about how you can work with TypeScript. I've actually written 2 blogs on the official developer.salesforce.com blog site. It's in 2 parts. In the first part, I talk about the type system. In the second part, I tell you how you can use it. And of course, the official TypeScript documentation is extensive. So if you start going over it, it's going to take you about 2-3 days to just get through the handbook. So refer to that. And hopefully this session was a little bit helpful, little bit insightful into how you can write better code. If you need to connect with us, you can feel free to follow these channels. We are on Twitter, we are on Facebook, we are on YouTube primarily under the Salesforce Developers channel. And of course, our whole new rebranded developer.salesforce.com website. So that's it for the presentation today. Any thoughts, comments, questions? Feel free to bombard me. Yes. Oh, multiple questions. On the platform at the moment, there are no plans yet. So which is why we're going to work with js.commons more on the platform. But off the platform, TypeScript is fully supported in Lightning Web Components. You had a question? Okay. Everyone had the same question? Okay. Yeah, not really. So what happens is, so in an SFDX project, there is actually a lot of types that are going on behind the scenes. So if you look at .sfdx, there are some typings that get automatically created, but these are very specific to the modules that you import. So whenever you're importing a schema in your Lightning Web Components, internally it has this type that we predefine. But unfortunately, it is not in the format that I have just shown you. So in your code, you need it in a format where there is a type and all the fields are present inside that type. So this is not that. Because we are automatically generating some things, I think we can put together a plugin. Again, it's our own effort because TypeScript is not supported and there are no plans that I know of. So maybe we can write a plugin to automatically convert this into the type definition we need. So there are bits and pieces out there. We need to figure out a way to combine them together in order to get what we need. So you had a question. Sorry, I didn't get that. Yes. Oh, right. You just put that into Git Ignore. So every project is going to have a Git Ignore file. If it is not there, you just create one. Basically, what it tells is what files should Git ignore when pushing the code to, I think it's going to be there on recipes. So what happens is generally when, let's say, you deploy your TypeScript project to a system like Heroku, it automatically runs your build script. So you technically need to just dump your source files onto GitHub, and the build process runs, which automatically generates the files for you on the fly. And this is the file I was talking about. So most of the build process, the build files that get generated can actively be ignored using this. It's totally up to you. I mean, if you want to build locally and only push the compiled code to production, that's totally up to you as well. Again, there is a lot of flexibility in what you want to do, but in general, the recommendation is the build file should never be pushed onto your version control. It's always supposed to be built on the fly. Okay, more questions? Everyone looks puzzled for some reason. So how many of you are going to start using js.comments from tomorrow? Only 3 hands? Okay. How many of you are going to start using js.comments from tomorrow? Okay. I was going to primarily start using it during concatenations because that's the place where most errors come up because of the type coercion that JavaScript does. Yes. Oh, yeah. Right. What we do internally is a little bit different. But yes, you got it right. So if you look at the jsconfig.json, there is a target that is specified where right now I said it is ES next, which is the latest version of ECMAScript. So what you could ideally do is you could take a TypeScript file and compile it into different versions. Let's say just ES5 version is the one that runs on Internet Explorer, and ES next is the one that runs on all modern browsers. So that way you can actually generate multiple assets of different versions using the same source file. And I think that is what we do internally. I don't know the internal processes, but yeah, I think this is my best guess. Correct. Yes. Oh, that's an interesting use case. All right. Oh, we are actually 4 minutes out of time. So thank you all for attending.